All right.
Number 10.
Number 10 was, I had a question there?
Yeah.
Okay, let's take a look. Number 10. And we had done the first 9, correct?
Yeah.
All right. 15z minus 9 quantity 2z minus 2. All right. How should I approach this problem?
You should multiply 2z and -2 by -9.
Yeah. So I have a -9 right here. I need to distribute it here and here. That is a huge error. People forget to carry the negative all the way through. So the -18 stays as is for right now. 15z stays as is. Then I get -18z and +18. Why is this now a +18? What happened? How did it make that happen? Yeah. Right. The negative times the negative makes it a positive. So I combine like terms. These are like terms here. What was that? -3z plus 18. Did I do that right? Now I'm going to subtract 18 for both sides. That's -36 is equal to -3z. What's my last step? Yeah.
Divide by -3.
Divide by -3. So I get z is equal to negative over negative is going to be positive, and 36 over 3 is going to be 12.
Oh.
Does that help you out? So how many made the error of not distributing the negative over the parentheses with the 9? Okay, at least one person's being honest. Cool. It happens. All right. Uh-oh. We have story problems?
Oh.
The difference of 6 times a number and 7 is 49. What does difference mean in math terms? Subtraction. What does 6 times a number mean? Like 6x? Cool. So let's just go through number 11, see what we do. So it says the difference, we're going to have subtraction somehow, of 6 times a number and 7 is in math terms is the equal sign, -49. So that's going to be how you're going to set up number 11. I bet you'll be able to do that pretty quickly. Okay, add 7, so 6x equals -42, right?
Yeah.
And then divide by 6. 42 divided by 6 is?
-7.
-7. So this was worked out. You should get -7. Cool. Number 12. Number 12 says -16 plus the quotient of a number and 4 is 3. -16 plus the quotient. What does quotient mean? Division. So it's some sort of division. It's going to be a fraction. Plus the quotient of a number and -4 is -3. Remember again, is in math terms is equals. All right, it looks like I could add 16 to both sides. Then what? Multiply by -4? I think -52 would be the answer.
Oh wait, no, I see. I
Oh.
forgot to put the
Right there?
negative right here.
Okay, yeah.
I was so confused.
I was going to say, I could totally make that error. Huh, okay. Can I move on?
Sure.
13, the sum of 2 times a number and 11 is 7. So the sum meaning it's going to plus, of 2 times a number and 11 is -7. 2 times, so doubling the number. So subtract 11. That's going to give you what? -18. Divide by 2. I'm just kind of trying to hurry through it. Ooh, this is like a big old story. Oh, I can't wait to find out the conclusion. The total cost for a week at camp is $220. You have $140 You earn 16 for every item you sell in a fundraiser. How many items do you need to sell to pay for the week at the camp? How many? Oh, okay. So it looks like the camp costs $220, and you already have 140 of it. So let's just figure out how much is owed. It looks like 80 is still owed for the camp. Is that all right? Yeah, I think we can do this. So you're going to start selling these tickets. So you're selling these tickets for every, you get $16 for every ticket. So we'll do that. So 16 times the number of tickets will hopefully get us 80. So if I divide each side by 16, 5? Yeah, sell 5 tickets. You get to go to camp. Woo! That's all we did, right? Hey, make sure your name is at the top of it. Did the no-namer that's going around find a name? It did. Make sure your name's on it and then resubmit it, please. Cool. Yeah, sometimes that happens. All right, so make sure your name's on the paper. Please hand it on in. And all right, everyone get one? You say who say no? Why you say no? All right, let's see. Warm up. 4x plus 5 equals 2x minus 11. What do you think? Extra?
11 plus 5.
How'd you do it? What'd you do? Go ahead.
You subtract 2x from each side.
Okay, subtract 2x from. Oh, come on, baby. You gotta work now. Oh, you subtract 2. What are you doing? All right. Yeah, you got that right. Well, I have to go the old school way. I gotta hand write it. So these should go along with what you have on your paper. Look at it. Okay. So I heard subtract 2x from both sides. I like it. That cancels that. Yes.
Sir.
What do we get? Help me out.
2x.
2x. What else? Plus 5. What else? Equals. What else?
-11.
There we go. How else should I do? Subtract a 5. All right. Woo! Let's cancel. What do we get on the left? 2x. What do I get on the right? Food? Negative 16, but close. And we'll undo this by dividing by 2. So we find. Sweet! X equals negative 8. We're there. Love it.
Yeah.
Can I move to the second one?
Yeah.
Got it.
Can you?
I don't know. Maybe. Second one looks like this. Uh-oh. I got y on either side. What should I do?
Subtract
Minus 1y.
Minus 1y? Okay.
No, then it goes
Sweet! Look what I got. Oh, what should I do?
Yeah, reverse that. Go
Subtract
back.
one.
Erase all that stuff.
Go back? Wait a minute. Why?
Because you need to subtract 2y.
Subtract 2y?
Yes.
Okay, I can do that too. Okay, cool. What should I do? What should I do on this one?
Then
Nothing.
divide by -1.
Divide each side by -1, so I get this. Sweet. This one's totally wrong because what I would do here is I'd subtract by 1. I'd get -1 is equal to y. And there is no way those are the same thing.
They're not.
They
They're
are.
backwards. It's called
Exactly.
reflexive property. And reflexive property is something that we accept worse than math. Yeah.
Could you subtract 1 first?
Sure, you could subtract 1 first. And yeah. There's all kinds of ways you can manipulate it around. So definitely, no matter which way you do these, as long as you're doing the operation, you might wind up with the letters on the same side as the numbers. Then you have to move the numbers at the end. So your choice how you want to go through it. Yes, -1 is equal to y is the same thing as y equals -1 because the reflexive property in mathematics is true. Okay? We okay? May I move on?
Yes.
All right. So let me ask one last question. Which is the correct way to do this?
The one on the right.
They're both correct. Some of your brains are going to see it one way. Some of your brains are going to see it the other way. But you both come to the same answer, which means that's awesome. You pick the way that your brain is working.
Yeah, I do.
Cool? But don't pick the way going, hey neighbor, I just copied. No, don't
Why'd you get
That's bad. All right, number three. Number three. 3x minus 2x equals 6 plus 4x. I do have some like terms. What do you think?
combine them?
Combine them. If I combine those together, what do I get?
X.
X. Is 1x and x the same thing?
Yeah.
Yeah. So I'm just going to put x equals 6 plus 4x. Uh-oh. Subtract the 1x. I could do that, or I could do this. It's either way is going to work. So I get negative 3x equals 6. Help me out.
Divide it by negative 3, and then you get x equals 2.
X equals what?
2.
Negative 2. So some of you had said, hey, subtract the x. You still would have gotten the same answer, okay? It's still going to work out.
Yeah. Guys.
I know I put negative.
Cool? All right, so now we have a process of boxes. Boxing. So we're going to kind of put a couple notes in there. There's going to be something I'm going to start showing you what to do when we start dealing with fractions, okay? And we can't run from fractions because they're going to exist. Okay, we don't have to like them. They don't have to be our best friends. We don't have to be following them on Twitter. Dude, there's a fraction Twitter account. Yeah, you got dude, fraction problem. Like, sweet, man, 1/2 plus 1/3. I can do this.
Is it verified though?
Yeah, it's 12/17, right?
What?
All right, so I'm gonna come back to these boxes a little bit.
What does LCD stand for?
Okay, so that's about as far as I'm going to get right now. So there's times when you get to a problem, you're like, okay, are there parentheses? And if there are parentheses, because parentheses are our first order of operations, can we do the mathematical operation inside the parentheses? That's the first thing to look at.
No.
Meaning, do we have like terms inside? If the answer is no, then we look at it saying, can I distribute over the parentheses?
You may.
Yes.
You
Okay.
may.
Who's on it?
I'll
Think they're funny there, sunshine?
solve it.
You're solving from.
What'd you say?
Is somebody humming? And you say,
Okay.
and you start threatening with your pencil. I'll solve it. Like, dude, you got sunshine back there. You got Cupcake who's saying he'll solve it. So.
That wasn't even me, that was this dude.
No,
Shut up.
She wants to eat cupcakes.
And then you got Farm Fresh Egg Boy back there as well. What does that even mean?
And then you have this one wanting to eat cupcakes. They're good.
This one Cupcake? No,
This
she's
is
Pookie.
happy
She wants
birthday
to
guy.
eat
She's Pookie.
Yes.
It's a good thing.
Can I be Snooki instead?
No,
You
Pookie.
got me in trouble.
I'll be sick.
Then you got Schwartz right over here.
Shorts.
Yeah, none of that.
All right.
And you have
So,
nasty up there.
nasty? Okay.
That's your favorite thing to say. You nasty.
Giddy up. All right. So, we are talking through this problem. So, parentheses first. Can I add the k and the 8 together to get 8k? No, it's not going to work that way. So then we have to distribute. We need to distribute something over the parentheses. So what are we distributing over our parentheses? The 3. Okay? Now, let me ask you all this. How would you solve that problem right there?
Just divided by 3.
Divided by 3. So hang on. So what if we were to tell you, if I did this to solve this problem, I could do this to this problem. What do you think? And then, so if you did it my way, you subtract that. So I'd get that. So some of you are going, I don't know. I don't think we can do that. That doesn't seem to work. So let's take a look. Doing it the other way, if I distribute here and here, that gives me 3k plus 24, right? Is equal to 21. How would I solve that? Subtract 24. I love it. Subtracting 24. So I'm going to cancel those. So I get 3k is equal to negative 3. And I divide each side by 3. And I wind up with k is equal to negative 1. So did I get lucky and discover a problem that you could do both ways just in a singleton case?
Yes.
Out of the infinite amount of numbers out there, an infinite amount of problems out there, I much doubt I got real lucky and chose the only one that could be worked that way. So if you have a number times a quantity, something in parentheses, okay, you could divide by what that number being distributed over the parentheses is to the other side, as long as it's just a number in parentheses. It might be a shorter way, okay? Which thought process is working for you? Some people might say this way works. Some people might say this way works. Which way is right? Both. Your choice. Okay? Feel okay?
Yeah.
All right. Can I move to the next problem?
Yes.
All right. So this next problem, we have this. So do you feel I could work it the new way? If so, what should I do to both sides? Divided by 2. So this is going to be one less operation to take place. So if I divide both sides by negative 2, that and that cancel. So I get x minus 3. Notice the parentheses are now dropped. Equals negative 6. And then from there, I'd add 3 to get that. So some of you who are still the doubters, I should have distributed over the parentheses. And subtracted 6. Okay, those cancel. So I get negative 2x is equal to 6. Divided by negative 2, x is equal to negative 3. Same answer, two different ways to approach the problem. What's better way? Your choice. I think the way on the left really does make it a little bit shorter in the long run, but let's face it, this doesn't take that long to do this problem. Is that okay?
Wait.
And why am I showing you both ways? Because sometimes people are sitting there and you're watching the same thing over and over and over again, doing the exact same motions, and it's going, it's just not clicking yet. And then I show you different ways, and then all of a sudden, for that person, I might be like, oh, because your brain works this way. You have something called synapses in your brains, which is the electric wiring of your brain. And sometimes, some of you might be able to go from point A to point B and solve it. And some of you might have to go from point A to point B to point C to point D to point E and then solve it. Whose brain is working better? They're both working the same. It's the same speed that it's going to take place. You're talking about close to the speed of light that this is taking place. So is there a difference in time between one person's brain and another? No. Okay? Yeah.
So do you want us to use the one on the left or not?
I want you to use the one that you feel comfortable with. Okay? And again, I'm just trying to show you the different approach that could work. It could be there it is. Okay? And I'm not trying to be the teacher that says, if you don't get it this way, I'm going to talk louder so you get it this way. That's not appropriate. I'm just trying to show you that there's a lot of times a different approach to a problem. Number 3. Can I move off this? Number 3. So I get 6 minus 2, parentheses, 3x minus 5 is equal to 40. Now, my new way doesn't really work on this yet. Why would I say that? Yeah.
Because you have an extra number that's not being distributed.
Right. So you have a little extra going on here, so take care of that. Do the opposite of it. That cancels that, and then I have this. Okay? So now this is one of the ways that we could solve it. I could divide both sides by negative 2 first. Or I could distribute the negative 2 over the parentheses. Okay? Yeah.
How did 3x?
Do what? Because I forgot to write it. That was that. Yeah, a miracle took place and I forgot to write it. No, wait. Were you just confused because I didn't put a 3x up there? Yeah, it was an accident. I didn't mean to forget it. So I make errors a lot. Sorry. That's why I record it and I go back all night long and just rewatch it. Oh, I gotta do it this way. One of these days, like in 20, 30 more years, I'm gonna become just an awesome teacher. But till then, you're stuck with me. Dude, you're an awesome student, man.
In the future, we probably won't have teachers. We'll have like a robot to teach us.
I really hope not, because we could become a very boring thing.
Robots that
Exactly. You guys are so
Did
you
you know
don't
that
have to pay them.
in the ICU they have robots that come out
They're gonna do your
Other
homework for you.
That way we can sit around all day playing video games, all the computers doing everything for us. And then we're going to really have an obesity problem on this planet. So I don't know, I've never told you all this, but no, I'm not a robot. As far as the stirrup lineage of my family, I am the most in shape. Like my family and I are the most in shape. My daughters, my wife and I are the most in shape of all of the stirrups that are from like my great grandfather's lineage down. I'll go back to North Carolina and see my cousins. They're smoking, eating like buckets of fried chicken, just eating sticks of butter, going, dude, check it out. If you take the stick of butter and you dip it in sugar and eat it, it's really good. And you're looking at them going, you're gonna die. No, I thought it hurt you. Hang on, oh darn, I just burned myself on my cigarette. It won't hurt you though. It's like, smoking's bad. No, they don't know what they're talking about. Okay,
It's not like
you're right. And then they'll tell me things like, you must be adopted, man. I got cousins, their arms are out here like this. I mean, they're heavy, heavy people. My Aunt Jackie, she passed away a few years ago, but she used to have this truck stop, and she had this biscuits and gravy. And the biscuits were like the size of the desk. It was just like,
Are you kidding?
she'd bring it out to you and be like, okay, I had a heart attack just now, but I think I might eat it. And they were wonderful, but boy, they weren't good for you at all. And she's, no, they're fine for you, sweetie. All right, back to our story. Let's see. Let's divide each side by -2. I like that. Whoop. Drop the parentheses. Add 5? I'm just verbalizing it. Adding 5, so I get -12. Divide by 3. Done. Yeah.
Could you do it a different way?
Sure.
Like,
Do you want me to distribute here?
yeah, like if you just like take away the 6 first and then you distribute.
Uh-huh.
Distribute it negative.
Heck yeah. So get to this point, subtract 10. Divide by -6.
You could do it that way too.
I'm just trying to share with you a couple different approaches. And again, which way works? Both. Which way's right? Both.
Is there a
Which
third
way does your mind work? The right way.
Is there ever gonna be
Sound
like
good?
Is there a third way to do this?
Well, for now, no. All right. I'm going to drop an F-bomb. Fractions. Here they come. The dude was going to say it. So I'm at the bottom of our page. And we all love fractions. Okay? We love fractions so much, I'm going to show you how to get rid of them. Is that all right? I'm going to get rid of them. I don't want them. You with me still in this situation? So does everyone feel that I have denominators, the bottom part, 1 being 3, 1 being 2, and the other one being 3? Still with me?
Yes.
Sir.
What is the smallest number that 3 and 2 go into?
6.
6. So what I'm going to do is I'm going to clear my denominator. I'm going to multiply this by 6 over 1, and this by 6 over 1, and this by 6 over 1. The reason I'm doing that is I have 3 terms. I have to do this exact same thing to all 3 terms. Still with me?
Sir.
Ready? Watch. Eyes up here before you start writing down. 3 goes into 6 twice. 2 times 1 is? Do you feel comfortable where that 2x came up from? What's the next one?
3.
Yeah, 3x, because this goes into this 3 times. 3 times 1, I get 3x. What's the last one? 3 goes into 6, how many times?
2.
What do I get?
20.
20. Why is it 20? Because
it's
2
in
times 10.
Oh.
Guess what? No more fraction. Then you can do this, combine like terms. Oh, I get 5x is equal to 20. Divide by 5, and I get 4. I don't know about y'all. That's a little bit easier way
Y'all.
than making 1/3 and 1/2, 5 over 6, and then multiplying by the reciprocal of 6 over 5. What? Yeah.
How do you get 6 in
Okay, because my denominators are both 3 and 2. So the smallest number that both 3 and 2 go into is 6.
Oh, okay.
And if I had like 3, 2, and 5, I'd multiply 3 and 2 and 5, and so I'd multiply everything by 30. Okay? So you got to take whatever your denominator is and figure out the smallest number that all the terms would go into of the denominators. And then you're going to multiply by that number over 1 to all of the terms. So this one had 3 terms, but it could have 4 terms, 5 terms, 10 terms, 100 terms. I hope not 100 terms. That's a lot of problems. A lot of stuff. All right, can I go to the flip side?
Sure.
There's a flip side. Wait, what about the diagram thing?
Yeah, I don't know.
Skip it?
I'm not sure what goes in those boxes. They were just there.
Yeah.
I was looking at it going, okay, distribute, cool, multiply, LCM, cool. Box, box, box.
There's like the boxes are just like.
I'm sure there's something really good that goes in there. I just don't know. I'm still new to this school. It's only my 3rd year here, so I'm still learning. All right, can I move on? I am doing it anyhow. A over 15 plus 4 over 15 is equal to 9 over 15. Now, this one's not horrible because my denominator on all 3 terms would be 15. So that would mean I should multiply each and every fraction by 15 over 1. And 15 over 1 is the same thing as just 15, right?
So it's just
So
a
that
one.
reduces here. So what do I have here? What does this become if I can't?
2.
That's
Oh,
an A.
1. Oh, I
Right? 15 goes in itself once. And then what does this one become? 4. And then what does this one become? And then A is equal to 5. No more fractions. Dude, if I only learned this like 5 years ago, it would have been so much better. Sounds like Mr. Sturp, my teacher said, your mom bought home 2 pizzas, 2 different sizes. One had 6 slices, one had 8. Your brother Billy ate 3 of the 8 slices. Your father Tom ate 2 of the 6 slices. How much is left?
All because
The
you don't share.
pizza.
It's all of it because you don't share.
Oh yeah.
I get. What I do? What?
It's all of it because you don't share.
I don't.
Exactly.
All right. Can I move on? We good?
Can.
Doing it. May I? 2 over 3 plus y equals 3 over 4. All right. What are my denominators?
2 or 3, 4, 1.
3, 4, and 1, because y could be over 1. What do you think I should multiply all 3 terms by? 12. The reason we're picking 12 is because the smallest number that 3 and 4 both go into is 12. So I'm going to multiply this by 12 over 1. Still with me?
Yeah.
And this by 12 over 1, which is the same thing as 12, correct? And this by 12 over 1. And then I'm going to start reducing. 3 goes into 12 how many times?
4 times.
4. So what do I have for over here?
8.
8 with no fraction. And 12 over 1 times y is the same thing as just 12y. Y'all okay with that? And then that goes in there how many times? 3. What do I get over here?
9.
Can I solve that?
Yeah.
Yeah. Subtract 8. Good. Divide by 12. Sweet.
Do you need to keep the 1 or can you just put 12?
Well, because the 1 is a placeholder because everything, it became just 1. So if I go 1/12 is a much different answer than 12. Is that right? This clearing the fraction thing might be an okay gig. I might be back on to doing math again, maybe if I don't have to do fractions. I was like totally chill with fractions when they were, everything's the same. And then I got chicken pox in 4th grade. Yeah. Don't worry, the shingles virus is now in my body, so I have to go get shingle shots now as an
Oh
adult.
my god.
Alright, just cough on me.
What? I'm
Don't
rude?
worry, guys. If you got chicken pox, you're all.
Wait, I have a question about this. Could you just times everything in the parentheses by 2?
Let's take a look. This one I could do 2 different ways. I kind of, I could distribute 1/2 inside,
1.5.
and then I got fractions inside.
Or you could just
Are
do
you
the
multiplying
same.
Well, is there one?
What?
Multiply it by 2.
Yeah, so right now I have 2 sides. I have 2 terms. I have this term here and this term here. And if I multiply over here by 2/1, I multiply over here by 2/1, then I get this. That means I'm going to go 1 distributed over 3x plus 6. Wait a minute. Isn't that just 3x plus 6?
Yes.
Okay. And then 2 times
Wait.
18. Subtract 6. Divide by tree.
By tree.
By
By
tree.
tree.
Wait, so I didn't
Be
mean like.
English.
Tree. 1, 2, tree.
Do you even English, bro?
C.
Oh, I see.
Oh, that bilingual.
Dude, cross-curricular curriculum. How cool is that?
This is confusing.
What do you mean? Where did I confuse you?
By the tree.
No, by
Tree and 3 are the same thing.
It's like all the fractions. I don't like them. So it's confusing.
Alright, can I move on?
It's like the, like,
I don't know. I think you're stuck. Okay. Alright, number 7. M is now our variable. We have it twice. What do you think our number to clear out denominators would be?
6.
6. How do we know?
It's 2 times 3.
Because 2 times 3. What if I pick some other number that 2 and 3 went into, like 24?
That's too big.
That's too, like, that's not the smallest number that.
Right, but would it still work, do you think?
Yeah.
Yeah, sure would. Absolutely. So again, you're trying to find the smallest number. So I'm going to multiply by 6/1. 6/1, same thing as 6, right? This cancels here, so I get what here? 3m. And then this cancels in there, so what do I have left here? 2m. And then what do I get here?
6.
Cool.
Wait, 6. Oh, I see.
What?
What's 3 plus 2?
I see what I
5m equals 6. So what's m equal to?
M equals 6 over 5.
1 and
M
1
equals 6/5 or 1 1/5. I like the improper fraction personally, but if you want to go 1 1/5, you can. I think I'm starting to understand this a little bit more. You know what? I can actually go out into society now.
Again?
I'm done.
Okay.
How can you do that?
I haven't been able to talk to anybody
When?
in 8 years. Because I didn't
This is when I'm helping you problem solve at a higher level of thinking. That's all math is really used for. Do you want to know when the last time Mr. Silva, my boss, came up to me going, okay, you have 2/3 x equals 6. How do we solve it? None.
What?
So you would think as me, I would be the one that I'd say, no, but math is used to allow us as humans to develop a higher level thought process. That's really the only thing it's used for. And people think, oh no, because then you get the guy, oh, I'm a doctor, I never use this. No, you've used some pretty good analytical skills in your life being a doctor. And these are skills that I'm teaching you. This is just exercise. It's like, when you're playing a sport, I don't know, or playing piano or whatever, doing whatever you enjoy, you practice at something that doesn't really fit the whole thing. Like right now with soccer, we're doing the 3v1 where it's in a box, and the girls are like, wait a minute, why do I need to use this? Because you want the person with the ball wants 2 different options to pass to. That's during the game, that's a good thing. So
So why haven't, like, the people who, like, research math found out dividing by 0?
they have. Goes along with the central limit theorem in calculus. But you're not there yet. You'll get there.
I don't know what that is.
It means you kind of approach it from either side, and then you can find what the limit is equal to. It's great. You love it. It's actually,
amazing.
it really is.
Sick.
No, it's not sick. All right, almost done. Number 8, 2 minus 1 over 4 m equals 3 over 5. How many terms do I have up there? 2. 3, good. What do you think my denominators are?
20.
Well, 20 would be what they would both go into. So 4 and 5. So I'm going to multiply all 3 terms by 20 over 1. 20 over 1 is the same thing as just 20. All right. What do I get here?
40.
40. What do I get here?
Negative.
80.
Right? What do I get here?
Oh, no.
12. Okay. Subtract 40. Yay. From that side, either side of the equal sign, that cancels. What is that? Negative 28. Good. Negative divided by negative, it should be positive. So I get m equals negative over negative, which is positive. 28 over 5 does not reduce. So there's my answer.
So wouldn't that be like 5 and 3/5?
5 3/5 or 5.6 or, but I like 28 over 5 as a reduced fraction. You guys ready for the last problem? No, let's hold off forever.
I think we should try this again.
Okay, go for it. Those of you who are stuck on it, multiply everything by 6 over 1. And I'm going to race y'all. I'm going to race you.
Oh,
I'm done.
wait, don't we multiply 6 by 14?
That's what I messed up.
Yeah. I get it.
Hang on. It's all reduced to. 3 goes into both. 3 goes in the top.
9 and
28 over 3. All right, so this is what I did. I hope I did it right. Did I do it right? What?
7G.
Yeah, it's 7.
Yeah, 7G.
What? I got, yeah, I have 7.
3 goes into 6 2 times.
Yeah.
Not 3
Yeah.
times.
And then you times that by 2, that's 40.
You mean I made an error right there? Oh,
Yeah.
shoot. That's a 4 then. That's a 7 then. And that's going to be a 7 there.
Which equals
And that's going to
12.
be a 12?
Yeah.
Oh, sheesh.
Yeah.
G equals 12. Boy, you guys are awesome. I can't do math. Don't tell anybody I don't know how to do math anymore.
So since we like
I'm telling.
did math and out math you, this is what we're
You
doing.
out math me?
Yeah, I think that should be.
Yeah,
more
like
homework
because we got
get
the answer and you
out now.
didn't, you should like get a passing grade for the semester.
Passing grade for the semester.
No, we should just get no homework this day.
Yeah.
Well, I'll tell you what. If you can finish this assignment, which is number 5A, which is page 15/16, if you can finish this before the end of the period, you're not going to have any homework. But if you can't, I'm just trying to give you the opportunity.
How much time is left in the period?
Dude, he's so mean.
10 minutes.
4 reading?
10 minutes.
No, about 20 seconds.
What?
About 20 seconds.